This is lesson 10.2, sketching y equals ax squared plus bx plus c. You should be on page 635. And yes, I didn't misread that. We are sketching. In this lesson, we're going to learn how to sketch quadratics when b is not equal to 0. Remember, in lesson 10.1, we did not have a b value. Let me cross this out. We didn't have a b value because b always equaled 0. But in this lesson, we're going to learn how do we sketch these when b equals something other than 0. Now, some of the things that you see here in the key concept box, properties of the graph of a quadratic, we've already learned. We've already learned that a quadratic has that form. We've already learned that a quadratic is a parabola. We've already learned that if the a value is positive, our parabola is going to open up. And if the a value is negative, the parabola opens down. We already know that. We've already learned that if a is a value bigger than 1, it's going to stretch your graph. And if a is a value between 0 and 1, like a fractional amount, it's going to shrink the graph. And there's one other thing we already know. We already know that the y-intercept of our parabola will be whatever the c value is. So if c was 8, the y-intercept's 8. We already know all those things from the last lesson. So what's new about this lesson? What's new is b is no longer 0. Now remember, in the last lesson, if b is 0, the axis of symmetry, and let me draw it right on here, if b is 0, the axis of symmetry is right on the y-axis. In this lesson, b is not 0. That means the axis of symmetry is moving. Now, how do we figure out where it's moving? We're going to have to figure it out by doing the following, where there's a little formula. Use this formula to find your new axis of symmetry. X equals negative b over 2a. You should definitely get that in your notes. X equals the opposite of b over 2a. That formula will show you where the axis of symmetry is at. Now, once you know the axis of symmetry, I'm going to use AOS to stand for axis of symmetry. Once you know the axis of symmetry, then you can figure out the vertex. Because think about it. Isn't the vertex always on the axis of symmetry? Isn't the low or high point of your parabola always on that mirror line, basically? And the answer is, yeah, it is. Okay? Let's actually go through the process with a sample problem. Let's consider the function y equals negative 2x squared plus 12x minus 7, and we're going to sketch this. Okay, so first step. A equals negative 2, B equals 12, C equals negative 7. Let's think about what these numbers mean. A is negative 2. That means the parabola opens down because we had the negative. It's also stretched. It's growing 2 times faster. Opening down and being stretched. C is negative 7. That means the y-intercept is negative 7. Now, B is 12. Now, remember, if B was 0, the axis of symmetry would be on the y-axis, but B is 12. That means the axis of symmetry is shifted. I got to figure out where. I have to use the formula. Let me highlight it. I have to use the formula x equals negative b over 2a to find out where my axis of symmetry is at. So let's do that. B is 12, so I have the opposite of 12. Over 2 times a was negative 2, and you notice when I plug that in the formula, I get negative 12 over 2 times negative 2, which is negative 4, and negative 12 divided by negative 4 is positive 3. So my axis of symmetry is at 3. So let me draw my axis of symmetry on this sketch, and I have that here. Okay, so this is 3 units to the right. Now remember, a sketch, we're not drawing it on graph paper, so I'm just approximating this would be 3 units to the right. Okay, now here's the next thing. If my axis of symmetry is 3, my vertex has to be on this axis of symmetry. So I want to figure out what's my vertex. Here's how you figure it out. I already know the x value of my vertex has to be 3, because do you notice the vertex is 1, 2, 3 to the right. I got to figure out y. Now, we're going to have to do a little mental math again, unfortunately. If you struggle with that, we'll have to work through it as best we can. To find out y, you go back to your equation, and where you see x, you're going to plug in 3. So let's do that. I'll write it down here. I have y equals -2. I have 3 squared plus 12 times 3 minus 7. Let's work that out. 3 squared is 9, so I have -2 times 9 plus the 12 times 3 minus 7. Let's do the multiplying in order from left to right. -2 times 9 is -18, plus 12 times 3 is 36, minus the 7, and now my last calculation. -18 plus 36 is +18, and 18 minus 7 gives me 11. The vertex must be 3, 11. So let's sketch that. 3 right, 11 up is up here somewhere. Okay, let me label my vertex. Next, my parabola opens down and is stretched, and there's one other thing. My y-intercept's at -7. So let's go down. If this is 3, 11, my y-intercept must be down about here at 0, -7. So here's my parabola. There's one branch. There's another branch. There's a picture of my parabola. Okay, now, you're going to see a sheet in a minute. There's a couple other things we're going to do on this parabola and label. This parabola has a high amount. Can you see that? This is called the maximum. This parabola has a maximum. The maximum equals 11. This parabola is 11 units high. It has a maximum at 11. One other thing I want to do is I'm going to have you label 3 points on your parabolas moving forward from this lesson on. So I've already labeled 2. 3, 11 is a point. So is 0, -7. Do you notice, here's my axis of symmetry. It works like a mirror. If this is 0, -7, there must be a point over here mirrored also. Now let's think about how to get to that point. From here to here is 3 units, right? Because there's the axis of symmetry, 3 units over. So from here to here, it must be another 3 units, which means this whole thing must be 6 units over, which makes this point 6, and it's 7 units down. That must be the point 6, -7. So I should be able to pretty easily label 3 units on my parabola. I got my vertex labeled right there. I definitely have a maximum at 11. Okay? Which gets me to page 636. They just talk about that. For standard form quadratics, the y-coordinate of the vertex is the minimum value if a is greater than 0. So in other words, if this is a positive, that means your parabola opens up, which means you're going to have a minimum. If a is less than 0, so in other words, if the number in front is a negative, like -3, that means the parabola opens down, and if the parabola opens down, it's got to have a maximum. That's what this box is telling you. If a is positive, I will have a minimum on my parabola. If my a value is negative, I'm going to have a maximum. Okay? This next slide, I would definitely make sure you get these notes down. From this point on, when you sketch a quadratic, I want you to label the vertex. I want you to label the axis of symmetry. I want you to label correctly 2 other points on the quadratic for a reference. I want you to determine if the parabola has a minimum or maximum value, and I want you to write what that maximum or minimum value is. So if you pause the video after writing this down, pause it, and then go back to page, well, not page, but this slide. I guess you didn't have to pause the video when I think of it. We could just go back to the slide. Do you notice all those things I did? Here's your axis of symmetry at 3. You have 3 points labeled, vertex and 2 others, and here's your maximum at 11. Okay? All right, let's do one more sample problem. Let's sketch y equals negative 3x squared plus 6x minus 5. Okay, so first of all, let's get out my xy axis. Let's do that first. Okay, I notice a is negative 3. That means my parabola is opening down and it's stretched. B equals 6. That means my axis of symmetry is shifted. I got to use the formula to find out where. C is negative 5. You know what I'm going to do right now? That's the y-intercept. Why don't I right now just go down here? Okay, I definitely know I have a y-intercept right here. I'll just put it on right now just because I have that. Okay. All right, let's get our axis of symmetry. It would have to be x equals negative b over 2a. I'm putting in 6 for b, so that's the opposite of 6 over 2 times negative 3. That's negative 6 over negative 6. My axis of symmetry is 1. So let's get out our ruler and let's draw our axis of symmetry 1 unit to the right. And there it is. Okay. Now, if the axis of symmetry is at 1, I'll label it AOS, x equals 1. That means my vertex has to be 1 comma something. I got to figure out what y is. Well, that's pretty easy to do. I got to take my equation. I got to plug in 1 for x and figure out y. So let's do that. Y equals negative 3 times 1 squared plus 6 times 1 minus 5. Okay, let's do that. I have negative 3 times, well, 1 squared's 1, plus I have 6 times 1 minus 5. And this would give me negative 3 times 1 is negative 3, plus 6 times 1 is 6, minus 5. And this would give me negative 3 plus 6, which is 3, minus 5, which is negative 2. So my vertex must be 1 right, 2 down, which is here. There's my vertex. And this parabola is opening down, because it's a negative for a and stretch, so my picture is going to look something like that. Okay. I got 2 points labeled. Here's 0, negative 5. Here's 1, negative 2. Let's mirror this over to here. Now, from here to here is 1 unit, which means from here to here is 1 unit, which means we have 2 units. This must be the point 2, negative 5. I definitely have a maximum on this problem, and my maximum would equal negative 2. So I've done all 5 things. I have labeled the vertex, I labeled the axis of symmetry, I correctly labeled 2 other points, I determined that this had a maximum, and I determined what it was. Okay? Find the minimum value of a function. The suspension cables between 2 towers of the Mackinac Bridge in Michigan form a parabola that can be modeled by this quadratic, where x and y are measured in feet. What is the height of the cable above the water at its lowest point? Now think about it. Can you see the parabola? The lowest point is the vertex. Well, to know the vertex, I have to know the axis of symmetry. So look what they do here. They're going to use the axis of symmetry formula. They'll take the equation, they'll take b and plug it in, and they'll take 2 times a and they'll plug that in. And they found out when they did that the axis of symmetry is 1910, which means the vertex is 1910, comma, some number. I just got to figure out that number. Well, that's easy. Take 1910, plug it in for x, just like we did in our sketches, and you can use a calculator, obviously, on this. And you notice they're plugging in 1910 into the quadratic, and when they do that and they plug it in, they're getting before that, 196. So the cable must be 196 feet above the water at its lowest point. I'm going to pause the video there. I think that's enough to get us through. Again, the problems where we're sketching, no calculator, but when you get to the word problems, you can use a calculator on those on the homework. I'll pause the video. If you have questions, make sure you ask in class.